We are going to talk about bone growth now. Let's go back and look at the bone. Bones can grow in length, it's longitudinal growth, and bones can become wider. That would be a positional growth. And when bone is growing in length, where exactly it happens? You would say probably at the very end, but no. That is the end of the bone, it's called epiphysis, and that is diaphysis. And between them there is epiphyseal plate or growth plate made of cartilage, hyaline cartilage. That is exactly where the bone growth is happening. If we take a piece of that cartilage and look at it closer under the microscope, that's what we're gonna see. On the top portion of it, closer to epiphyseal part, end of the bone, there will be cartilage. New cartilage cells will be formed right there, again and again and again. Old cells will finally die and be replaced. They will be replaced by the bone tissue. The process is called ossification. So on the epiphyseal side of the bone right here, cartilage is formed. On the other side, on the diaphyseal side, cartilage is ossified. It means cartilage dies and becomes bone. So the diaphysis, the middle portion of the bone, is growing in length. When bone is completely formed in adults, usually after 18 years old, bone growth stops, and those growth plates close and become bone tissue, and you only can see tiny line on the surface of the bone, which is called epiphyseal line. So epiphyseal plate or growth plate becomes epiphyseal line in adults. You can see it in the x-rays. That is x-ray of the child's hand, wrist. And those are ulna and radius, and right here you can see open growth plates. That's where there is no bone, there is cartilage right here and right here. In adult, there are just lines, hardly visible right here on radius, but on ulna you can see visible closed growth line, epiphyseal line right now. Bones are also growing in widths. That is called appositional growth. Bones are like tubes. Inside there is a medullary cavity. So when we make that bone wider, and how it's being made wider, on the outside osteoblasts would be layering depositing new bone tissue on the outside, and inside osteoclasts would be removing bone tissue. So it's still a tube, but right now it's a wider tube in adults. That process, of course, takes years. It happens very slow. So that reshaping of the bone while a person is growing is called modeling. When people are adults already, the bone shape also can be changed, but now in adult it will be called bone remodeling. So reshaping bones in adults is remodeling. It's a lifelong process. And when bone was damaged, broken, the old damaged bone will be removed. Bone resorption. What cells will be doing that? Osteoclasts, of course. And new bone tissue will be formed. Bone deposit. That will be done by osteoblasts. When can it happen? Injuries, broken bone, of course, reshaping of those bones or replacement of some bone tissue. Then microdamage. Microdamage actually happens with each of us almost every day. Whenever we're doing something a little bit outside of our regular activities, when we jump or when we run, exercise, or lift something heavy, microdamage can happen to our bone tissue. It's absolutely safe in most of cases, and those bone tissue will be repaired immediately. And finally, bone remodeling happens in response to functional demands. If you look at swimmers who swim for years, every week, several times, you will pay attention, you will see that their arms, their bones of their arms and shoulders are wide and well developed. Why? Because they exercise them a lot. So responding to functional demands. In average adults, remodeling process happens at about 5 to 10% of bone tissue per year. It means that every 10 years, each of us receives a completely new skeleton. Okay, so two processes are happening during bone remodeling: bone resorption and bone deposit. How exactly it happens? Remember those huge cells that have many nuclei, osteoclasts. Osteoclasts are sitting on the surface of the bone, and they can secrete two substances, lysosomal enzymes right here, and those enzymes will digest organic matrix of the bone. Remember what is organic matrix? Those are cells like osteocytes, and those are also collagen fibers. Those will be digested by lysosomal enzymes. But osteoclasts also produce acids, and those acids can destroy calcium phosphate. Calcium salts are converted into soluble forms, and they go into the blood. So whenever bone resorption is happening in the body, calcium level increases in the body, in the blood. Bone deposit is a slightly different process. It's adding bone. When bone is injured or additional strength is required, our osteoblasts add additional bone tissue. What is necessary for that? Diet rich with all those building materials: proteins, calcium, phosphorus, magnesium, and also vitamins C, D, and A. Osteoblasts will deposit osteoid seam. It's a matrix, and later that matrix, made mostly of fibers, will calcify. Spaces between fibers will be filled with calcium phosphate. Here is a link to YouTube video, and I will leave that link in the description of this video. So please click on it after you're done with this video, or just right now and watch that video. Now we'll talk about bone fractures. There are several types of bone fractures, and you need to know their names. First one, how they are classified. By 4 either or classifications. First would be position of bone ends after fracture. When ends retain normal position, bone is broken, but bone ends are not moved. That would be non-displaced fracture. Or it can be much worse, displaced fracture. And of course, those sharp ends will damage surrounding tissues, nerves, blood vessels, and muscles. Next one would be completeness of the break. A break can be complete, going all the way through the bone, separating it into two parts. Or it can be incomplete break, or just fracture. Very often it's called green stick fracture. It happens mostly in children. So it's just cracked bone, not broken bone. Next one, by orientation of the break to the long axis of the bone. Linear fracture is parallel to the long axis of the bone. Here it is. And it can be transverse, perpendicular to long axis of the bone. Next one, bone ends can stay in place or just be displaced a little bit, and there is no damage to the skin, maybe some damage to surrounding tissues. That is called simple or closed fracture. But in the worst case, bone ends can be displaced a lot, penetrate through the skin, causing open wounds. That is your compound or open fracture, which is much more dangerous, and not only because of the great damage to the bone, but also damage to the muscles, nerves, blood vessels, skin. It's open wound, so blood loss can occur and infection can enter the wound and cause severe damage to the tissues.